I'm Hareesh Singireddy. I'm a solutions architect at AWS. So my role is to help customers through their cloud journey and be a cloud advocate and help them both in terms of technology, operations, or entire thing about cloud, right? And today I want to talk about harnessing the power of data with AWS. All right, let me quickly move on. So in today's world, data is kind of everywhere, and it's easily available and securely available to anyone who needs it. Data has become sort of an organizational asset, and it comes in many different shapes, formats, and sizes. So it could be terabytes, it could be petabytes, and sometimes even exabytes. But the real value of data is to identify opportunities for business growth from the data and act upon those opportunities faster. And the way you can do that is by putting your data to work through analytics, through ML, to make maybe better decisions in your business, create efficiencies in your processes, and drive new innovations in your business. And there are three key phases that we look at in the journey to becoming more data-driven. So the first step is to modernize the data infrastructure to get off of on-premises databases and onto a more modern cloud data infrastructure. And second is liberating the data by breaking down the silos and then making the data more accessible to everyone inside your organization who needs it. And third, once you have the data available to everyone, and the third is to innovate with that data using AI and machine learning. And today, I'm going to focus more on the second and third phases. So moving on to the second phase that I mentioned, liberating the data. So if you look at traditional data warehousing approaches today, as you accumulate so much data, a lot of the data lives in different silos. So it's really hard to do analytics when your data is stuck in different silos, basically. And it can cause problems like the data might be split across multiple different stores and can be inaccessible, or the silo where the data lives might not meet the price performance requirements of your application. Or these silos might require different management, different security and authorization approaches, which basically increases the operational cost and risk that you have to handle with all of the different data stores that you have. And the way you can liberate the data from these silos is using a modern architecture that we call lakehouse architecture. And this is how lakehouse architecture on AWS would look like. This is an example of the architecture. It gives you an overview of how it's set up, but the services that are mentioned here are some examples of how the entire architecture would work, right? So what this architecture is giving you is a highly scalable, available, secure, and flexible data lake that can handle extremely large data sets, which is using Amazon S3 behind the scenes. And this data lake can store your structured data, your unstructured data, and you can use open data formats of your choice, like Parquet or ORC. And you can tag the data in a central searchable catalog using Glue Catalog. And once you have the data in a central location in the data lake, you can then use purpose-built database and analytic services like EMR, Elasticsearch, or even Redshift to make sure that you're using the right tool for the job to get the high performance and scale while also keeping the cost low. And you have around the perimeter, you can see there are multiple different databases. Not all applications might need a relational database. Some workloads work better with NoSQL databases. Some workloads work better with graph databases. So having that purpose-built data stores around the data lake and having the ability to move the data around is really important. And to move the data around, you can use AWS Glue. It's a serverless data integration service that lets you move data between these systems. It could be inside out or outside in or even around the perimeter. And finally, to create the data lake architecture and to set all of this up, you can use this service called AWS Lake Formation, which makes it easy to set up the data lakes in days. And you can also manage the security and governance of the data, regardless of whether it sits in the data lake or purpose-built data stores. So you now have a central location that can and have a unified governance that's also performant and very cost-effective to store and analyze the data and get more insights out of the data. And once you have the data architecture set up, now let's look at how you can use AWS ML capabilities to innovate with your data, right? So you've probably heard of these technologies described in a number of different ways. So let's take a step back and level set on what they are. Right? Artificial intelligence is think of it as a way to describe any system that can replicate tasks that previously required human intelligence. So almost always this is related to some kind of complex decision making where human judgment was required. And most of the use cases are looking for a probabilistic outcome, making a prediction or a decision with a high degree of certainty, almost similar to a human judgment. And almost all of AI systems today are created using machine learning, which machine learning uses a large amounts of data to create and validate a decision logic, also known as a model. And your application then feeds input data into that model, and the model outputs human-like decisions. So machine learning behind the scenes is the underlying technology that's powering the intelligent systems. And another flavor of it is deep learning. Deep learning is a type of machine learning that uses techniques known as deep neural networks. So these systems replicate how the brain functions. So this lets AI systems address more complex use cases than what was previously possible. Right? Now, at AWS, we are innovating on behalf of our customers to deliver the broadest and deepest set of machine learning capabilities for builders of all levels of expertise. So when we think about ML at a macro level, we're thinking about having three layers of the stack. At the bottom layer is the frameworks, the interfaces, and the infrastructure, mainly for expert ML practitioners. So, for example, there are three frameworks that are predominantly used: TensorFlow, PyTorch, and Apache MXNet. Right? And new algorithms are constantly being developed in all different frameworks. And people want to run in that framework instead of porting the algorithms to a different framework. So what we've decided is to dedicate teams for all major frameworks, so you can use whichever framework is right for your use case. And similarly, at the infrastructure layer, we have the broadest and deepest set of ML infrastructure services to meet unique performance as well as budget needs. So for example, EC2 P4D instances use the latest NVIDIA Tensor Core GPUs and 400 gigabits per second instance networking. And they give you the highest performance for ML in the workload. You can choose to run your ML frameworks and your model inferences and trainings on these instances. And for inference, once you have a model trained, for inference, you can use EC2 Infun instances that are powered by AWS Inferentia chips, which provide high performance and lowest cost inference in the cloud. So there are two major parts of machine learning workflow: model training and inference. So model training jobs process hundreds of different data samples in parallel, but when you're going to inference, they're usually processing a single input in real time and consuming a small amount of GPU to compute. So having a standalone GPU just for inference is cost inefficient, right? And different machine learning models might have different CPU, GPU, and memory requirements. Some might require higher GPU, some might require more memory, and things like that. So optimizing for one resource can lead to underutilization of other resources and higher costs. So basically, to solve these problems, Amazon Elastic Inference allows you to attach just the right amount of GPU-powered inference acceleration to your EC2 instances, to SageMaker instances, or even ECS tasks, so that you can optimize for your memory and CPU and add on GPU as you require to make machine learning inferences. Moving on to the middle layer of the stack, this is for everyday developers and data scientists that are not expert ML practitioners. You just need to build, train, and tune ML models. You don't need to worry about running those EC2 instances, making sure the containers are up to date, the latest AMIs are available for running those EC2 instances, all of those things. At the middle layer, the core service is Amazon SageMaker. SageMaker removes complexity from each step of the machine learning workflow, so you can more easily deploy your machine learning use cases. So anything from predictive maintenance to computer vision or predicting customer behaviors. And it has capabilities to help you throughout machine learning workflow. For example, for data preparation step, you have SageMaker Ground Truth to help you label data. Model building stage, you have SageMaker Jumpstart, which offers pre-built solutions for common use cases. And in training and tuning stage, SageMaker Debugger can help you debug and profile training runs. And once you have a model trained and tuned and ready for deployment, SageMaker offers a one-click deployment solution, as well as SageMaker Pipeline to orchestrate and automate the entire ML pipeline. And you can do most of that from the SageMaker Studio. It's a fully integrated development environment designed specifically for machine learning. So this will get more towards everyday developers who have knowledge of machine learning, who like to get their hands dirty with building their own models and creating their own models. Next up, at the top of the stack is the AI services. So these are for developers and organizations who want to add solution-oriented intelligence to their applications, probably through an API call, rather than developing and training their own models in SageMaker. And we have a lot of services in this area to address needs, including industry-specific services like, for example, Lookout for Equipment that recently went into GA, that's designed to help customers in manufacturing, agriculture, energy, or other heavy industries. Right? And for example, Amazon Health Lake is specifically made for our healthcare and life sciences customers. And apart from the industry-specific services, there are also services that can handle common data types like vision, audio, video, text, images, and things like that. So for example, recognition can help you answer questions like, tell me what's in this image, or which celebrities are in this image. And speech services like Poly can help you turn speech into text. Transcribe can transcribe audio. Translate can help you if you want to translate text into different languages. And if you want to understand what's being said in those translated corpuses of your text, you have Comprehend, which extracts meaning from the data. And if you want to extract text from documents, you have Textract, which is helping you extract not just like an OCR to extract from text from that data, but it can help you recognize data structures like tables within your documents. Then you have things which are Amazon is relatively famous for and cover specific types of use cases. For example, Alexa and chatbots with Lex, or personalization for personalized recommendations and forecasting. And all of these AI services at the top layer lets you easily add intelligence to any applications just by using those services API, right? And now that you've seen the ML stack, in addition to providing all of these resources and capabilities to build your own models from the scratch, or even through SageMaker, aiding you build those models faster, or even using pre-built AI services to add intelligence to your applications, we're also thinking about where your data is. So we're bringing ML services directly into databases, that integration into data warehouses, data lakes, and BI tools. So what it means is this ties back into the lakehouse architecture that I mentioned earlier. You have purpose-built data stores, databases, and the data analytics services that suit for a specific type of data. And having your models run on SageMaker, or now you need an integration between these two sets of services to automate or to make your machine learning predictions faster and integrate your applications better and basically reduce the complexity. So think of integrating an ML model running on SageMaker into your own application that's probably using a relational database. So You have to write application code to read the data from the database, format the data that's suited for the ML model, call the ML service to run the ML model on the formatted data, get the output, and format the output for the application, and then load the results into your application. And the complexity keeps increasing if you have multiple data sources to pull the data from. So to solve that, so one of the services, one of the capabilities that we have is Amazon Aurora ML, right? So with Amazon Aurora ML, you'll be able to call an ML model on SageMaker directly from SQL, and the results are returned to Aurora ready to be used. So for example, in a product recommendation use case, the SQL query can itself pass information like customer profile, shopping history, product catalog data into a SageMaker model, get the results from that model in terms of product recommendations, and then return that to the application. So now your application only has to interface with Aurora through standard SQL and user-defined functions that would call the ML models on SageMaker and reduce the complexity and have a low latency real-time predictions, ML predictions into your application. Similarly, Amazon Athena is an interactive query service that makes it easy to analyze data that's sitting in S3 using standard SQL. You'd be able to run SQL queries on top of the data that's sitting in S3 without moving the data outside of S3. And with Amazon Athena ML, you can write SQL statements similar to Amazon Aurora ML. You can write SQL statements that run ML inference using SageMaker. So we are bringing that integration into your where your data is and what tools you're using to work with your data. And for example, and if you're using Amazon Redshift for your data warehousing needs, Redshift ML, a feature in preview right now, will let you create, train, and apply ML models directly from SQL. So you can use a create model command and select appropriate columns in the data set to create and train that model. Behind the scenes, Redshift works with Amazon SageMaker Autopilot to select the most optimal ML algorithms based on your data. And finally, once the model is ready, the model will be deployed locally in Redshift with optimized tuning. And now you can run inferences just as invoking a user-defined function as part of the SQL statement. So we're bringing that integration into your data warehouse. Another type of database that we've seen customers use heavily is graph databases. So Amazon Neptune is a fast, reliable, fully managed graph database service. So graph databases are often used to store complex relationships between data in a graph model. These things include, for example, knowledge graphs used by search engines, or graphs of models of disease or gene interactions, the relationship between, for example, in a financial industry, the relationship between financial and purchase transactions to aid in fraud detection. So these are all the use cases that fit really well to a graph database. And with Neptune ML, it does the hard work for you to select the graph data needed for ML training, automatically choosing the best ML model for the data, exposing ML capabilities via simple graph queries so that you can include in your applications, and also provides you templates so that your developers can customize ML models for advanced scenarios. And with ML that is purpose-built for graph data, using SageMaker and Deep Graph Library, you'll be able to increase the prediction accuracy by over 50% compared to the traditional ML techniques that we use for other types of data sets. Moving on from databases into a more business intelligence tools, Amazon QuickSight provides you out-of-the-box ML insights on your data. So QuickSight integrates with SageMaker Autopilot again to enable business analysts to do things like anomaly detection, forecasting without any heavy lifting. So let's say if you have a time series data that you've grabbed in your dashboard that's showing you, revenue across years of revenue values, right? And QuickSight can automatically recognize patterns in that and detect anomalies inside the data, or forecast how your revenue would look like in next couple of quarters without any heavy lifting of building that model or thinking of training the model, all of those things. So it can do that all of those things behind the scenes. And QuickSight also has a great feature called auto narratives that uses ML insights to tell customers the story of dashboard using plain language narratives. So you'd be able to add those auto narratives to your dashboard, which will in plain language explain what's going on with the data. For example, you have seen 50% revenue increase year over year in this quarter. So it'll be able to recognize those patterns and automatically create those auto narratives for you that you can use in your dashboard. And another new capability of QuickSight that is in preview currently is Amazon QuickSight Q. Right? So QuickSight Q is a deep learning powered capability in QuickSight that empowers business users to ask questions in natural language and get answers instantly. What this means is your business users can ask questions about the data they're using every day in business language that's most natural form. There's no need to learn and remember complex syntax to query the data. There's no need to understand which data sets you have access to, all of those things. And the benefit of doing that is that business users can now ask ad hoc questions to get answers that goes beyond the known questions that are captured in the pre-built dashboard. So when you're building dashboards, you're usually thinking about what a particular set of business units are looking for. But at runtime, when they're looking at a dashboard, they might ask an ad hoc question that combines a different data set with the data set that in hand and get insights from the data. Right. And lastly, it's with Amazon QuickSight Q, it's incredibly easy to set up and get started. It's in preview today. All it takes is a couple of clicks and it's ready to answer questions in minutes. So to recap, we have looked at the three phases on a path to success: are modernizing your data infrastructure, liberating data using lakehouse architecture, and innovating with ML services and built-in ML capabilities in many services. And I want to reiterate that having a good data architecture is really important to be successful in getting analytics and insights from your data. And the way you do it again is through lakehouse architectures and using all of those ML capabilities that's available, standalone AI services, or ML SageMaker, or even the ML capabilities in many of those AWS services. That's it. Thank you, everyone, for joining this session today. You can learn more about AWS ML capabilities and ML services and the new innovations that are being developed by AWS at ml.aws. And again, I'm Hareesh Singireddy. I'm a solutions architect at AWS. You can reach me at the email address here on the screen, and that's my LinkedIn profile name as well.